I started by weighing out our ingredients. Here are 30 grams of potassium nitrate, 15 grams of cane sugar, and 7 grams of Karo syrup. Later on, we'll use some red iron oxide, but that's irrelevant at this point. We wait till later for that. You may note that there's water heating in the electric skillet. This is because Karo syrup is a rather sticky substance and doesn't come out of the pan very thoroughly by itself. So I'm going to add some water anyway. It might as well be hot water. We'll use it to rinse out the Karo syrup. I'll pour some in here. I need 30 milliliters. Where is that? Oh, got way too much. So I'll pour out most of this. 30. Water amount isn't really critical in this particular recipe. So if I have a little extra, no big deal. Into the pan in just a moment. Extra water has been poured out of the pan, so now I can add the potassium nitrate, the sugar, and the water and corn syrup together. And turning on the temperature to 300 degrees Fahrenheit. Yeah, those numbers anyway. In the meantime, we should document what's being done here. 50 grams potassium nitrate, USP grade, 25 grams sucrose. Started it cooking. Okay, let's see what happens this time. Okay, looks like everything's dissolved, so I'm going to let it cook until it starts forming crystals. Day to day. Like that. And you might also note that I've not been wearing gloves up to this point. I believe that when the stuff is a thin solution, there's very little risk of it catching fire. But as the waters start to cook out, the risk increases and increases to the point where there's a real hazard. And at what point is it a real hazard? I don't really know, but I like to start wearing gloves pretty soon. So you can see how it's beginning to crystallize. I call this the crystal mush stage. It's pretty mushy, but it's getting some solids in it too. Now from here on, we should be stirring almost constantly. Notice what I mean by stirring is a combination of mixing and mashing. I want to mash the propellant down to where it contacts the surface of the pan as much as possible. That maximizes heat transfer and makes it cook more quickly. I also keep disturbing it. And every now and then, I'll go around the pan and tidy up. Gather stuff that's working around the edges, consolidate it, and then smear it out again. Soon, we'll want to do a test and see if it's solid enough to hold its weight. Let's call it the snap test, including this one. Okay, now it's time for the knife. With a knife, I can scrape off the spatula. Now here's where we start getting samples to test. I'll take just a little bit, and I'll put it on this clean, cool plate. Finger, I'll risk a finger for that. And then I'll touch it gently. Let's see. Oh, it's kind of stiff. Oh, it's almost crumbly, but it doesn't feel very sticky. You can tell at this point, if it feels sticky, it's not dry. If it feels unsticky, then it's getting dry enough. This one has a little bit of residual stickiness to it, so I'll leave it here on the plate to continue to cool. And I'll try it for a bend test in just a moment to see if it snaps. That's another clue as to when it's getting done. When you can smear it out nice and flat like that. See how it has that putty-like texture? The more surface area exposed to the pan, the quicker it heats. The more surface area exposed to the air, the quicker it dries. So you want a thin layer. And you want to keep disturbing it. Keep working it. This looks good. So I'm going to gather it up into a blob, scrape it off with a knife, take what I feel will be a representative sample, and we'll give it a test. Right. Take it gently off the knife so it doesn't stick to me if it's sticky. Rolls into a ball nicely, mashes flat nicely. Doesn't feel terribly sticky. That's a good sign. So I'll let that cool completely, bend it, and see what's going on. In the meantime, that feels good. I'm optimistic that this batch is about ready. So, back to the pan. We're going to cover this blob. We don't want it to cook a lot more. I like to cover it with that little pan lid. That helps keep moisture in while it keeps it hot too. We're cooking at 275 degrees now, which is a good temperature for that. It'll cook a little bit, but not real fast at that temperature. To double cover is also a good idea, especially on a breezy day like this. That helps keep the heat in. So So let's go back to our sample and see where we're at with it. What I want to do now is to bend it and see if it breaks. But first, I'll drop it. It clinks. That's a good sign. I'm going to bend it a little bit. It snaps. It has passed the snap test. That means our propellant is dry enough and we can work it. So, back to the pan. Okay, got one more test to do, and that's for a burn rate test for this plain propellant. Now we're going to change the burn rate by adding a catalyst in a little while, but we want to see how the plain propellant burns as much out of curiosity as anything. So I'll grab a little sample, set it down here on the cloth board, and cover the pan. I just want to protect it as much as possible, and us as much as possible. I'm going to turn the temperature down even further to about 225 degrees. Okay, we got our slug of propellant. Going to roll it out, roll it out, roll it out into a strand about 1/4 inch diameter. And then we want to cut it 1 inch long. So I'll make it reach from the 5 to the 6 inch mark here. And chop it off. Roll the end smooth. Pack it in a little bit. With a nice tidy end. So you can squeeze it shorter if you wish, or roll it to make it longer. Let's see, a little too short. I'll roll it a bit. Okay, that's about 1 inch. We're going to call that close enough. I'll throw this little sample back into the pan so we can join the rest of the propellant. I'm going to carry that 1 inch strand, and then let it cool a little while, and put it on a can some distance from our cooking pan. We don't want any risk of setting that on fire. Now I'm going to light one end of it real quick. I counted out about 12 seconds there. Time to add the catalyst. Now we've weighed out 1/2 gram of red iron oxide. Get back to the pan, get our gloves and glasses back on, and mix it in. There we go. Dump that powder. And then we're going to make this propellant a very pretty color. I'll leave the sunlight on it so you can see how rich and red it becomes. Does this color look vaguely familiar? Look like the classic brick red color? Well, it ought to, because red iron oxide is the substance that's used to make bricks red. It also makes them harder. It also changes the texture of this propellant somewhat. It makes it more creamy and easier to work. Okay, so now that we've got that more or less mixed in, where's my scraping knife? Okay, got it. Scrape it all off. You can see there's a big unmixed spot. Oops, don't want that. Now that I see that, I'll squish it in again. I want you to do a lot of stirring and mashing with this propellant recipe. The more you mix it, the better it gets. But once we have what looks like a very thorough, even mixture, I'll take another burn rate sample. I think we're about there. Scrape this off. Okay. Grab another little sample, about that much. Okay, back to the cloth board. Scrape that bit off and let it sit just a moment so it's not too hot to touch. Let's see if this is touchable. Yeah, and it's just about soft enough to work. Let's see how much this strand weighs. 2 grams, almost to the penny. Let's see how this burns. It should be a bit faster. I counted 6, maybe 7 seconds, so that very nearly doubled the burn rate of this propellant.